To facilitate construction and transportation, equipment is necessary. The crawler-type crane with a 30-foot boom and 9 tons capacity is the heaviest crane used. It may be used with a drag line, shovel, or backhoe. With a specially developed sling, the crane can handle 8 fuel drums at one time or serve as a pile driver if properly rigged. The operator's cab is already closed. The engine fan is, however, modified so that engine heat is kept enclosed or directed into the cab. Ice grousers may be added to the flat pad tracks if the crane is to be moved on ice. The crawler-type crane is a dependable piece of equipment. A smaller crane, commonly called the cherry picker, is also much used. The cherry picker has been given several modifications. An insulated plywood cab with double plexiglass windows is added to protect the operator. It is a crawler-type tractor equipped with a 12 to 18-foot boom with a capacity of 1 to 5 tons. On the larger cherry picker, the air intake is changed so that air passes over the exhaust manifold before going into the cylinders. The cherry picker is invaluable for handling relatively light loads. A forklift is another piece of equipment used for construction purposes. It is also used for material handling. The forklift uses the same tractor as the cherry picker. The lifting and hoisting jobs in Pet 4 are adequately taken care of by these pieces of equipment. Another item of equipment, the D8 tractor, is also used for construction purposes. The chief overground personnel carrier is the Weasel, the Army M29C. Its tractor-type tracks can move the vehicle at speeds up to 30 miles per hour. It has been considerably modified for Arctic use. An insulated plywood cab protects personnel from the cold. The escape hatch on top is a way out if the Weasel should break through the ice. These Mark I treads have been replaced by others having the newly designed Mark III bands. The Mark III bands contain more cables and are stronger than the Mark I. Reinforcing rings are welded to the front idler wheel to help it withstand the shock of rough terrain. Rubber bumpers are installed on the bogie wheel support arms to keep tension on the tracks and to absorb shock. Finally, heavier spring leaves are installed, making it necessary to cut out the strut on the bogie wheel yoke. The Weasel has several strong points. With careful driving, Weasels have traveled over 2,000 miles without change of tracks or major overhaul. It is amphibious, traveling in water, which it can enter and move through without conversion. It can climb a 40-degree grade and descend a 60-degree slope. Rough terrain does not stop it. In spite of the modifications made, however, it has numerous weaknesses. It was designed as an expendable military vehicle with a maximum life of 1,000 miles. A similar vehicle of sturdy construction designed for long Arctic life with a minimum of maintenance is greatly needed. A second piece of transportation equipment is the diesel-powered D8 tractor. It is a standard heavy tractor. It may be used with such accessories as winches, V-type snowplows, dozers, or rooters. Relatively few modifications are made on the D8 for Pet 4 operations. A large insulated double-windowed cab is added. There is an escape hatch on top. The radiator is covered to keep engine heat inside. At the tracks, deep and sharp-biting ice grouser pads provided with holes to break the snow replace the construction-type grouser pads. And skid blocks made of hardwood replace the carrier rollers because the rollers freeze and wear out rapidly. The D8 is used chiefly as a prime mover for tractor trains hauling supplies. It is also used for such construction work as grading for airstrips, roads, and building foundations, preparing the beach for unloading supplies, and for trail blazing, snow removal, and general maintenance work. The D8 is the most dependable piece of equipment used in Pet 4 operations. It has no basic weaknesses. The few failures encountered have been generally due to flaws which escaped factory inspection. Excellent preventive maintenance has kept failures to a minimum. Sleds of various kinds are necessary pieces of transportation equipment in Pet 4 operations. The sled that has proven most satisfactory is the modified Michelin number 9 heavy duty. It has 4 independently mounted runners connected by chains or cables which synchronize the direction of the runners and make the sled maneuverable. This sled carries a payload of 20 tons. Over rough terrain, the pedal motion of each runner tends to take the shock rather than the entire sled. The runners are made of laminated hardwood with a 6-inch metal shoe and side plates. The construction provides excellent ground clearance. The modified Michelin gives as much clearance as possible with good stability. Another type of sled is made of welded pipe and was designed and constructed in Pet 4. Its construction gives moderate ground clearance and excellent shock absorption, yet it sinks into snow less deeply than does the Michelin. As with all sleds used in the Arctic, an important feature is the special drawbar used to connect sleds together or to a tractor. Such cargo carriers may haul large numbers of oil drums, heavy loads of drill pipe, lumber for construction work, pallet loads of general stores and supplies, any material not subject to weather damage. An enclosed body called a wanigan is also put on sled chassis. All wanigans, regardless of use, are constructed similarly. The floor is double with a paper liner between layers. The walls and ceiling are also double with insulation between outside wood and inside building board. When completed, all wanigans look generally alike from the outside, although varying greatly in size. The use of each type is clear from their names: the utility wanigan, drill wanigan, food storage wanigan, fuel wanigan, and shop wanigan. Sleds and wanigans pulled by D8s provide mobile shelter as well as the means of transporting supplies in quantity over ground in Pet 4. Another piece of equipment, the U.S. Navy LVT-3, has been modified for Arctic use. An insulated cab with good visibility and an escape hatch on top has been added. Air scoops replace the larger air intakes to the engine. It can travel over snow, ice, and mud. It can swim through water. It fills a definite need. At the engines, vapor-type standby heaters have been installed to keep crankcase, radiator solution, and battery warm during shutdowns. Added fuel capacity increases the range to 350 miles. Warm air from the engine, taken from just behind the radiator, provides heat to the cab. A Magnuson-type compass and a two-way radio are also installed. Additional modifications should be considered. The LVT will not back in water or in mud because of the shape of the grouser pads. The bilge pump rotors tend to freeze. A clutch should be added so that the pumps may be readily engaged when needed. It is necessary to stop the propeller shaft before reversing to avoid damaging the transmission. An odometer should be installed so that mileage covered can be accurately determined to assist winter navigation. The gasoline engines are less economical and a greater fire hazard than diesels. The LVT promises to be a useful cargo hauler. A body similar to the Wanigan is sometimes placed on a weasel chassis. It can readily be towed from place to place over all kinds of terrain. It houses the recording apparatus, radio, and generator for seismograph survey party. Such a weasel, because of its springs, gives better protection to the scientific equipment than would a sled chassis. A few other pieces of equipment find a limited use in Pet 4 operations. Weapon carriers and trucks transport cargo in camp areas where there are roads. The 15-ton Athey wagon, a standard trailer with crawler-type tracks, is used frequently for short-distance hauling. It is slow-moving and does not stand up well on rugged terrain. The chief problem, besides low ground pressure in operating equipment in Pet 4, is the combined problem of engine starting and lubrication. Normal lubricants and diesel fuels become stiff and solid at extremely low temperatures. At the same time, storage batteries are reduced in efficiency. Storage batteries with an electrolyte of high specific gravity are used to lower their freezing point. The batteries are kept fully charged and are insulated from the cold. This Herman Nelson 250,000 BTU per hour aircraft type heater is then used to warm the engine. At minus 40 degrees Fahrenheit, it may take 2 hours of preheating to start a gasoline engine or 4 hours to start a diesel engine. On the trail, engines are not stopped. They remain running during all rest periods, waits, turnarounds, or stopovers. For out on the trail, there are no facilities for starting cold engines. There are other possible solutions to the engine starting and lubrication problem. One ideal solution would be to design new equipment that will operate satisfactorily in the extreme cold. Another ideal solution would be to develop Arctic lubricants and fuels that will work well in present equipment. Either or both of these ideal solutions are vitally needed. Another possible solution is to use a slave kit, which combines an external heater with heavy-duty starting batteries. Units of this type have not yet proved satisfactory. Still another possibility, though not recommended, is to dilute the crankcase lubricant so that it pours readily at the atmospheric temperature. Any such diluent must burn off quickly, or the lubricant will be too thin at engine operating temperature. In practice, diluents have not burned off in the Arctic. In the selection of any lubricant or diluent, it is important to note that some cause serious corrosion inside the engine because of condensation of moisture. Lubrication is, of course, also required in transmission, final drives, track rollers of tractors and weasels, and in the gearboxes and travel gears of cranes. In all these places, lighter grades of greases designed for Arctic use are required. A second problem in the operation and maintenance of equipment is the behavior of equipment materials at low temperatures. Steel, for example, becomes brittle when extremely cold. Dozer blades must bite in gradually and carefully, or corners snap off. Another characteristic of steel is the tendency to freeze solidly to snow and ice, especially when under pressure, as is the shoe of a sled runner or the track of a D8. When shoes are to stand for long periods, planks are placed under sled runners and tracks. Other material used in equipment gives difficulty at low Arctic temperatures. Treated canvas becomes stiffer than untreated and rips and tears readily when handled. Plastics become brittle and shatter easily. Synthetic rubber tires and synthetic rubber electrical insulation reacts to the cold in a fashion similar to plastics. A third problem of operating equipment in the Arctic is maintenance. A great deal is required because of the extreme cold and the rough terrain. For the repairs that cannot be avoided by preventive maintenance, a warm shop and well-trained personnel are necessary. Only in a heated workshop can mechanics work at full efficiency. Only in a shop can one have hoists for heavy lifting, as of this D8 transmission housing. Here are power tools, presses for installing spring leaves on weasel springs, and assemblies for installing new tracks. If the shop is to operate efficiently, equipment must be standardized, and spare parts must be interchangeable to the fullest extent possible, so that relatively few special tools are needed, and only a few trained mechanics and shop personnel can maintain and repair the equipment. Wherever possible, equipment needing anything but the most minor repairs should be brought back to a shop where the work can be done efficiently. When the emergency requires that repairs must be made on the trail, great care must be taken. It is extremely difficult to make satisfactory welds in the open when the air temperature is below 0 Fahrenheit. The equipment now used for construction and transportation in Pet 4 has, on the whole, done its job well. True, it has had to be carefully maintained. Operational care has been necessary. However, for Arctic operations, constant improvements in the equipment, in maintenance methods, and in operational methods are vital. Greater emphasis must be placed in guided research and testing to provide more adequate equipment to do the work for future Arctic operations.